Number 7 is find the length of the curve y equals x cosine x over the interval 0 to pi. And the formula for the length of a curve is a definite integral from a to b of square root of 1 plus f prime of x squared dx. And what we need to find are a, b, and f prime of x. A and b are already given here. They're 0 and pi. And f of x is given here, so we need to find f prime of x. So take the derivative of x cosine x, and you get x times negative sine x plus cosine x. So negative x sine x plus cosine x. So our integral is from 0 to pi of 1 plus cosine x minus x sine x squared dx. And we just put this into our calculator. So integral from 0 to pi of the square root of 1 plus cosine x minus x sine x squared dx, and that is 5.52. So 5.52 units is our final answer. Number 8 is find the length of the curve x equals 1/2 y squared plus y minus 1/2 from y equals -1 to y equals 3. And even though for this one this has x as a function of y, our domain is still from a y value to a y value, so we can just swap the y's and x's and everything would work the same. So the definite integral would be -1 to 3 of the square root of 1 plus the derivative of a function squared. So we have to find the derivative of this part. So d over dx of 1/2 y squared plus y minus 1/2 is equal to y plus 1. So y plus 1 squared dy. And when we put this into our calculator, we don't need to put y's in place of the x's. We can just put x's instead of y's, and it would still give the same answer. So the square root of 1 plus x plus 1 squared dx, and we get 9.29. So 9.29 units is our final answer. Number 9 is a particle moves along the x-axis so that its velocity at time t, for t is from 0 to 5, is given by v of t is equal to ln of t squared minus 3t plus t. The particle is at position x equals 8 at time equals 0. Part A is asking find the acceleration of the particle at time t equals 4. And what we need to do first is find our acceleration function. And our acceleration function, as you should know already, is the derivative of the velocity function. So we just take the derivative of this, which is 2t minus 3 over t squared minus 3t plus 3. And we plug in t equals 4 to this. So a of 4 is equal to 5 over 16 minus 12 plus 3, 7. So 5 over 7 units over second squared is our final answer. Part B is find all times t in the open interval t is from 0 to 5 at which the particle changes direction, during which time intervals for 0 is less than or equal to t is less than or equal to 5 does the particle travel to the left. So to find the times t where it changes direction, we can graph the function of the velocity and see where it switches signs. So the function of our velocity is going to be ln of x squared minus 3x plus 3 graph this. And now we have our zeros here where it switches signs, and we need to calc them using calculator. Left bound here, right bound here. So we have 1, 0 at t equals 1. And let's find the other one. Left bound here, right bound here. Another one at t equals 2. So the particle changes directions at t equals 1 and 2. And during which time intervals for t 0 to 5 does the particle travel to the left? And we're assuming that the positive direction is the right direction. So when the graph is positive, it's moving to the right. And when the graph is negative, it's moving to the left. And we can see that it's negative between our zeros, so between 1 and 2. So during which time intervals? It's from 1 to 2. It's traveling to the left. And that's our final answer. Part C is find the position of the particle at time t equals 2. What we need to do is kind of find the function for the position, which is just the integral of our velocity. But what we can do is, since we're given a specific point to find, we just take the integral of velocity from 0 to 2. And the integral of our velocity is going to be our displacement, or how far it is from the origin. And taking it from 0 to 2 is going to give it, as time goes from 0 seconds to 2 seconds. So definite integral of 0 to 2 of ln of t squared minus 3t plus 3 dt. And plug that into our calculator. From 0 to 2, ln of x squared. We're replacing t for x here. Minus 3x plus 3 dx. That should give us 0.369. And remember, we need to add that to our initial position, x equals 8. So add 8 to that, and we get 8.37. So 8.37 units. Probably meters, but yeah, 8.37 is our final answer. Part D is find the average speed of the particle over the interval t from 0 to 2. And you should know that the average speed means total distance traveled over total time spent. And time spent is obviously 2 seconds. And the distance traveled, well, we already have a formula for the displacement from 0 to 2. But the distance is going to be a little bit different. It's still going to be integral from 0 to 2. And the function of the velocity is still going to be the same, but we're going to have absolute value signs around the velocity, because instead of taking the velocity, we're taking the speed, and the speed is just absolute value of velocity, I think, because it's scalar, not vector. So put this into your calculator, and it's going to be integral from 0 to 2 of absolute value of ln x squared minus 3x plus 3 dx. We get 0.74, but divide by 2, it's 0.37. So 0.37 units over second squared, probably, oh no, units over second, so probably meters over second, but our final answer is 0.37. Number 10 is a water tank at Camp Newton holds 1,200 gallons of water at time t equals 0. During the time interval t from 0 to 18 hours, water is pumped into the tank at the rate of W of t is this gallons per hour, and in the same time interval, water is removed from the tank at the rate of R of t is equal to this gallons per hour. Part A says, is the amount of water in the tank increasing at time t equals 15? Why or why not? So to find if it's increasing, we need to see if the rate of which is being pumped into the tank is more than the rate of which is being removed from the tank. So W of 15 is greater than R of 15. First, we need to find W of 15, and we can use our calculator for this. 95 times square root of 15 times sine of t over, or 15 over 6 squared. And that's 131.7, so like 132. And R of 15 is equal to 275 times sine of 15 over 3 squared, which is 253 gallons per hour. So the water is being removed faster than the water is being added, so no, it is not increasing, and that's our final answer. Part B says, to the nearest whole number, how many gallons of water are in the tank at time t equals 18? And first, what we can do here is we need to combine both the W of t and R of t equations to get an equation where it just gives us how much water is being added at that moment. Because if you think about it, how fast the water is being added is how fast the water is being pumped, and you remove how fast the water is being removed from that. So we can say like F of t, where F of t is like how fast water is being added or moved if it's negative, is equal to W of t minus R of t. And so what we need to do is find the integral of F of t from 0 to 18, because the integral of F of t is going to be how much water has been added from that point, and the point we want to find is from 0 to 18. So we just plug this into our calculator. So integral 0 to 18, and remember F of t is Wt minus R of t, so Wt first, 95 times square root of x times sine of x over 6 squared minus 275 times sine x over 3 squared. And then with respect to x, that should give us 109.788. So 110, we can say. We can say this is equal to 110. So that means after 18 hours, 110 gallons of water have been added in total. And we need to add this to the 1,200 gallons of water that it started with. So 1,200 plus 110 equals 1,310 gallons. And that's our final answer for part B. Part C says, at what time t in the interval 0 to 18 is the amount of water in the tank at an absolute minimum? Show the work that leads to your conclusion. And in part B, we kind of already established that we can write the amount of water that has been added after t equals 0 as an integral, with our left bound being 0 and our right bound being the time. And we can set this as a variable b because we're trying to find the time in our equation. And F of t dt. And remember from our derivatives unit how to find the minimum and maximum. We're focusing on the minimum here, but to find your extrema, you have your function, and the derivative of that function, you set it equal to 0 to find your extrema. So let's do that with this function. Find the derivative of this, and the differentiation cancels out to the integration, so it's just f of t as our derivative. And we set this equal to 0, and we can just do that by putting it into our graphing calculator. 95 times square root of x times sine of x over 6 squared minus 275 sine of x over 3 squared, right? Yeah. And now we should edit our window. So let's set our minimum to 0, our maximum to 18 because that's the interval we're in, and look at the graph. So now we can see, besides from the endpoints, we have two places where we have a minimum or maximum. But remember, a minimum is when the curve of the graph goes from decreasing to increasing. And in other words, at the minimum, the graph is going from decreasing to increasing, or the derivative is going from negative to positive. And the only place where it does that is at this point right here, this first place where my mouse is circling. So let's calculate what that is. So 0, see if we can find it. Okay, left bound here, right bound here. And it gives us x equals 6.49. So yeah, t equals 6.49 hours. And that's our final answer for part C. Part D says, for t is more than 18, so after 18 hours, no water is pumped into the tank, but water continues to be removed at the rate r equals t until the tank becomes empty. Let k be the time at which the tank becomes empty. Write, but do not solve, an equation involving an integral expression that can be used to find the value of k. So basically, when the time is 18, we had calculated that there are 1,310 gallons inside the tank. And after that, only water is removed, nothing's added, so we have to find this at time where 1,310 gallons are removed. So we can say the integral from 18 to k of r of t dt is equal to 1,310, because the integral of r of t is just how much water is removed, and we're taking the integral after 18 to some hour k where all of it's removed, or it's all 1,310 gallons removed. So let's replace r of t with the actual equation, 275 sine squared t over 3 dt equals 1,310. And that should be our final equation and our final answer for part D.